Hi guys, I Aziz welcome you to Codemaster, and in today's session we are going to learn about web workers. So before we start, let me set the agenda for today's session. So I have split this session into two sections. In the first section, we will learn the theoretical concept about web workers. In the next section, which is a practical lab section, we will see how to create a dedicated web worker, how to create a shared web worker, how communication happens between main thread and the web worker, and we will see how they differ from each other. So without wasting any time, let's get started. So let's first start with a very simple question, that what is a web worker? So guys, web worker is a JavaScript object which allows us to run a script in a background thread entirely separate from the main thread. So when we run our application in a browser, our browser spins up a main thread, which is this thread, and this thread takes care of our application. But apart from this, we can also spawn a worker thread, and we can assign some task or script to worker thread for execution. So this raises a question, that what code we can run inside a web worker? Well, you can run whatever code you like to run inside the web worker. For example, you can call any function, you can make network request, you can use objects like string, array, object and JSON, correct? But there are some exceptions. The first exception is, as the window object is not available in the worker thread, you cannot directly manipulate the DOM inside the web worker. And the second exception is, you cannot use some default methods and properties of the window object. And why is it so? Because the window object is not directly available in the web worker. Alright, let's move on to the next slide. So far we know that what is web worker and what code we can run inside the web worker. But you might be thinking that how main thread is going to communicate with the web worker. So guys, the communication happens between main thread and web worker via a system of messages. So when we spawn a web worker, there is a communication channel which is going to be established, and using that communication channel, we can communicate from main thread to worker thread. So how it happens? So let's say after establishing a communication channel, let's say the main thread wants to send a message to worker thread, then it's going to send a message via a post message call. So the post message is a function call, and we are going to pass a message or an object to it, and the worker thread receives the message. How it's going to receive the message? Worker thread has to register a callback function on message event handler. So when main thread sends the message, the worker thread is going to receive the message on the callback, which is registered on message event handler. In a similar fashion, when worker thread wants to send the message to main thread, it has to call the post message function call, and the main thread has to register a callback on message event handler. So far so good. Let's move on to next slide. So as we have seen in the previous section, that main thread can send the object to the worker thread. So you might be thinking that how this data transfers happens between main thread to worker thread. Is it going to be copied from main thread to worker thread, or is it a shared object? Which means, is it shared between main thread or worker thread, or it gets copied structurally entirely for a worker thread? So the answer to this question is, data is always copied rather than shared. So for example, if main thread is sending any object to worker thread, the entire new copy of that object is created inside the JavaScript runtime, and then that copy is delivered to worker thread. Now, which algorithm is used inside for this computation? So there is one algorithm which is already available in JavaScript runtime, which is a structured clone algorithm. And what it does, it's create the entire new copy of that object and pass it to worker thread. As simple as that. So instead of keeping the references of object, which is where we get when we do a shallow copy. Rather, it creates a deep copy of an object, and it creates a deep copy and pass it to worker thread. So far, so good. Now, the question arises that can we spawn new web workers from the existing web workers? The answer to this question is absolutely yes. You can spawn new web workers from inside the existing web workers, but there is one condition. Both the worker and the child worker must be within the same origin as the parent page. So for example, if you are running a worker thread on the origin https://example.com:433, then when you spawn new web workers or child worker threads, all the child worker thread should reside under the same origin, and the origin is a combination of protocol, which is HTTPS, the domain, and the port number. So as long as your worker thread and child thread resides within the same origin, you can spawn as many worker thread you want based upon the number of cores of your machine. So let's say you have 4 cores and 8 virtual cores on your machine, then you can probably spin up 4 worker thread or 8 worker thread, right? All right. Now we know about what are web workers, how communication happens between web workers, what code you can run inside the web worker. But the question over here is how many types of web workers we have. So guys, we have in total 4 types of web workers. Number 1 is the dedicated web worker. So dedicated worker is also a type of web worker, but dedicated worker is accessible by the script that created it. So let's say there is a script.js, and this script is created a dedicated worker. Then only this script can access this dedicated worker. Why? Because this dedicated worker is created by a script.js. The next worker we have is a shared worker. So shared worker, as the name suggests, it will be shared among multiple scripts. So let's say we have a script1.js, script2.js, script3.js. Then this shared worker can be shared between script 1, 2 and 3 all along. Okay. The next web worker we have is a service worker. So the service worker is a special type of web worker which act as a proxy and which sits between web app and the network. So let's say you want to send the push notification, you want a background fetch, you want a periodical sync, then all of those stuff will be performed by service worker, and service worker also intercept the request as well, and it also helps in caching the response by intercepting the network request. Moving on, the next web worker we have is the audio worklet. So as the name suggests, it's going to work for the audio only. But why the name is worklet? Because it is not a exactly same copy of web worker. It is a lightweight web worker. That's why the name is audio worklet. What is the purpose of audio worklet? Using the audio worklet, we can process the audio inside the browser. So it's a lightweight worker for audio processing. So far so good. So now we know that there are 4 different types of web workers. Number 1 is a dedicated, number 2 is shared, number 3 is service worker, number 4 is the audio worklet. So we will see the examples of dedicated and shared worker in the practical lab section. So far so good. Let's move on to the next slide. Now, context is a very important key in JavaScript. Whenever we run a function, the context is created. Whenever we run a script, a context is created. So definitely when we run a web worker, the context must be created. So how many different types of context we have? So first, a generic context we have is a web worker global scope. So it's a global context which is inherited by all the scopes, okay, or all the context. So for dedicated worker, we have dedicated worker global scope. For shared worker, we have shared worker global scope. For service worker, we have service worker global scope. And for audio worklet, we have audio worklet global scope. So what is the purpose of web worker context or a scope? So a scope is nothing but it's a context which is created when we create a web worker. So when we create a dedicated worker or shared worker, a scope or context is created. And the context is the thing where they store all the variables, all the function calls, all the function call chain, and all of those stuff. We can say the event loop, micro task queue, macro task queue, and all of the stuff will be stored in the context. All right, now we know pretty much about web workers, what code we can run inside the web workers, how communication happens between main thread and worker thread, how data is shared, how can we spawn a web worker, type of web workers, type of web worker context, but we didn't answer yet that what is the need of a web worker. Do we really need web worker or not? So here let me give you the 5 solid reasons why we need a web worker. So the first reason is non-blocking UI. So what happens when we run our application? The main thread is started and the main thread takes care of our application. And let's say if we give the heavy computational task to our main thread, then main thread becomes busy in executing those heavy computational tasks and our UI becomes block, or we can say our UI becomes freezes, will give a sluggish behavior and becomes non-responsive. So if we want our UI to be as responsive as possible, then we can always delegate the computational intensive task to a web worker to make our UI non-blocking. The next strong reason for using a web worker is a parallelism. So let's say nowadays our machines are coming with a more power, more cores. So we have 4 cores, 8 cores, like that. If we do not leverage the web workers and we simply run our application on the main thread, then our only one core is usable. Means we are only leveraging the one core. If we want to leverage all the cores or multiple cores of a system to make our application more performant, then we can always create a web workers to take advantage or leverage the multiple processor to improve the parallelism and concurrency. Now the third reason is performance boost. So as I said that if we give the computational intensive task to a main thread only, then our performance of website will hinder. To maximize the performance of our web application, we should always offload the CPU intensive tasks to our web workers. Okay. The next reason is separation of concern. So nowadays we are shipping a hell lot of code in the front end. And to maintain the entire code base, we need a cleaner architecture. And if we combine our UI logic inside the heavy computational intensive logic, then it quickly becomes cumbersome. So to have a cleaner architecture, we should always write a UI logic separate from the computational intensive logic. So when we use a web worker, we have a separation of concern that we write UI logic in a UI part and we write the computational intensive code inside the web worker. So it helps us in separation of concern. The last but not the least is the background processing. So if you want to do a background fetching or background syncing or data processing without blocking the user interface, then we should always prefer web workers. And why is it so? Because again, if we give all of these heavy tasks to a main thread, then may be possible that our UI becomes non-responsive and user may feel or user may see a very bad experience. So far, so good. So we have reached the last section of our session, which is a practical lab. Now I will give you a code walkthrough where I will show you how to create a dedicated worker, how to create a shared worker, and then we will see the behavior. Okay, so let's jump over to VS Code. But before I show you the examples, let me show you what is the consequences of running a computational intensive task on a main thread. Okay, so here in the example 1 section, we have index.html, and here I have written a very simple code base. So let's run this example. So here you can see that we have uh, we have two buttons. One is going to print the hello world on the console, and we have run computational intensive task. Okay, so this example is example where we are not using any workers. Let me show you the code. So here we have a simple styling, then we have two buttons. I have given the IDs to two buttons, and on click of button 1 we are logging hello world on the console. Then on the click of button 2 we are calling Fibonacci function, and you can see that I have written Fibonacci function over here. It is a computational intensive function because the complexity of Fibonacci function is big of 2 to the power n. Okay, now let's see how the computational intensive task impact the performance of the application. So if I click print hello world, you can see the log on the console again. So I have clicked print hello world 4 times, so we got the logs 4 times. Now let's click second button. So when I click second button, we are giving the computational intensive task to main thread. Now as soon as I click run computational intensive task, our UI becomes block or unresponsive. Now I am not able to click the print hello world button at all. And why is it so? Because main thread is busy in executing the Fibonacci function rather than listening for the click events. And I have clicked the hello world 14 times. So the main thread was busy calculating Fibonacci of 45, which is this number, and it took 10 seconds to compute the results. It is really a heavy intensive task, heavy computational intensive task. So this is how when you give computational intensive tasks to main thread, our UI becomes unresponsive and you are not able to click or do anything else. So this is a very bad user experience, right? So how are we going to solve this problem? So we are going to solve this problem using a web workers. So let's close this example. Let's stop the server. Let's go to example 2 and click index.html and open worker.js. So now you can see over here that I have moved the Fibonacci function from index.html to worker.js. Now let me give you a code walkthrough that how can we create a dedicated worker. So here this example is using dedicated worker. We have again two exact same button. On button 1 click, I am logging on the console. So here I am checking if we have web worker feature available on my browser, then I will execute this code. Otherwise I will log your browser does not support web worker. So this is the code which is going to create a dedicated web worker for us. The name of the object is worker and we are passing an object. In the object we are passing a name of that worker. Okay. Now we are registering a callback on the button to click, and what we are doing, we are calling post message method of my worker by passing 45 to it. Okay. And then again on my worker we are registered a callback function on message event handler. So by using post message we are sending messages to web worker, and by listening on message event handler we are listening for the incoming messages from web workers to main thread. Okay, I hope the code is very straightforward and you really understand it better. So here on worker.js I have written Fibonacci function and I am listening for on message event. So when we get the message from the main thread, we are extracting the data by using event.data property. We get the number, then we are calling Fibonacci of number, and then again we are calling post message method to post the message back to the main thread. So let's run this example and see how it works. Okay. So now we have again two buttons to print the hello world and then to run the computational intensive task. So this example is using a dedicated worker. Okay. Now if I click hello world, you can see that I am clicking hello world multiple times from main thread. Okay. So I clicked print hello world 10 times. Now let's click run computational intensive task. And you can see that message is posted to worker thread received the message, and I can still click the hello world right here. You can see here the logs coming up, and then worker thread posting message back to main thread receives the message from worker thread, and it prints the output of Fibonacci of 45, and it took almost 10 seconds. So you can see the difference that in previous example, when the computational intensive task was running, we were not able to click the button at all. The UI freezes. But now in this example, as we are using a web worker, we are able to click the button, which means our web application is still responsive and listening for new events. Why is it so? Because we delegate the entire computational intensive task to a separate thread. So far, so good. So I hope you understood that how dedicated web worker is created and how it works. Now let's go on to next example. The next example is about shared worker. So for shared worker, we have two pages, page 1 and page 2. And again we have worker.js. So I have written the same boilerplate code for shared worker as well. So here we are checking if we have worker feature available, then we are creating a shared worker over here. So instead of worker object or worker class, we are using a shared worker now, and we are giving a name straightforward right here. The first argument is the script URL and the second argument is the name of the shared worker. Now again I am registering a callback function to button 2 where we are calling myworker.port.post message, and then I am listening to on message event on the myworker. Now the question over here is that why are we using port over here? We were not using port in the dedicated worker. The reason is quite simple. The dedicated worker is only for one script, so that's why there is a channel which is established in the background to make communication happens between main thread and the worker thread. But here, as the worker thread is used by multiple pages or multiple applications, we need some communication channel where main thread can communicate with worker 1, 2, and 3 and 4. So to differentiate the multiple workers, the concept of port comes in, and all of this stuff, the creation of messaging channel and port is done by the browser itself or JavaScript runtime. So which is why we are posting a message from the port. So for example, if we are running example 1 or script 1, then the port 1 will be used, and if we are running script 2, then port 2 will be used. All of these are the implementation details which is abstracted away from us. Okay. Again, after getting the message from web worker, we are printing and doing all of this stuff. Okay, let's go to index2.html. This script again has the same boilerplate code where we are creating shared worker, registering a callback function on the click event of button 2, and then we are listening for the new messages. As simple as that. In the worker.js, now instead of directly listening for the on message event, now we are listening for the on connect event. Why? Because now this worker will be accessed by the multiple script. So first we are listening for on connect event, then from on connect event we are extracting the port, and then we are listening on this port, and inside of this port we have the same exact code where we are logging, extracting the data, calling Fibonacci, and posting message back to the main thread. Okay, and here we have Fibonacci function. Now let's run this code. So let's click go live. Here we have shared worker 1, and then here we have shared worker 2. Okay, now let's open up the developer console, and then on page 1 let's click print hello world. I'm able to click on page 2, I'm able to click print hello world. Now let's click run computational intensive task. You can see that message posted to worker, and then you can see over here message posted to worker. But you might be thinking that why the workers logs are not coming over here, and the reason is pretty simple. As we are using a shared worker, the logs will not come here. You have to go to Chrome Inspect or Brave Inspect if you are using Brave browser. Go to DevTools, go to shared workers, and you can inspect over here. Now you can see that messages is coming from main thread to worker thread. See, worker thread, message received from the main thread, posting message back to main thread, again message received from the main thread, and posting message back to main thread. So you can see like this. So first I click the computational button on page 1. So main thread is posted message to worker, then message received from the main thread, then posting back to main thread, and message received from the worker. And you can see it again took the 10 seconds to compute the Fibonacci of 45. Similarly, on page 2, we send message to worker, then worker receives the message from main thread, worker posting message back to main thread. We got the message from worker thread, we are printing here, and then the console dot time is giving us a 15 milliseconds. So the first example took 10 seconds, and the second example took 15 seconds to compute the Fibonacci of 45. So guys, this is how we can create a shared worker and consume or used by multiple scripts. So guys, I hope now you have a very good understanding about web workers, how web workers works, how communication happens between web workers, how to post message from main thread to worker thread, how to listen for messages in main thread and worker thread, and pretty much everything about web worker. So guys, if you really learned something valuable today, then please subscribe to my channel, like this video, and share with your friends. And thanks for watching. See you in the next video.